Analytical Conics by D.M.Y. Sommerville. Chapter 6, The Parabola. Section 1. The parabola was defined in Chapter 4 as follows. A is a fixed point, and AX a fixed straight line. P is a variable point, PM perpendicular to AX. Then the locus of P, such that PM squared equal P dot AM, where P is a constant, is a parabola. Chapter 6, The Parabola. Section 2, Equation of the Parabola. To find the equation of the parabola in its simplest form, take A as origin, AX as axis of X, then AM equal X, MP equal Y, and the equation is Y squared equal PX. It is more convenient to write this Y squared equal 4AX. A is evidently the length of some line. By taking different values of A, we get parabolas of different sizes. It is just as if we draw the same curve on a different scale. Hence, all parabolas have the same shape. Assuming A to be positive, we see that X must be positive. Hence, the curve lies entirely to the right of the y-axis. Otherwise, X is unlimited in magnitude. The curve extends to infinity. Since y only occurs squared, the axis of X is the axis of symmetry, and there is no other axis of symmetry. The parabola is a very specialized type of conic, and it will be found that while it has numerous properties similar to those of the ellipse and the hyperbola, it differs from them in many ways and requires special treatment. Section 3, The Tangent. To find the equation of the tangent at a point P equal x sub 1, y sub 1 on the curve, we shall find the equation of the chord joining P to a point Q equal x sub 2, y sub 2 on the curve near to P, and then let Q approach P. The equation of the chord is y minus y sub 1 divided by x minus x sub 1 equal y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Since both P and Q lie on the curve, y sub 1 squared equal 4a x sub 1, and y sub 2 squared equal 4a x sub 2. Therefore, y sub 2 squared minus y sub 1 squared equal 4a times the quantity x sub 2 minus x sub 1. Hence, the gradient of the chord is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 equal 4a divided by y sub 1 plus y sub 2. As Q approaches P, y sub 2 approaches y sub 1, and the gradient approaches 2a divided by y sub 1. Hence, the equation of the tangent at x sub 1, y sub 1 becomes y minus y sub 1 equal 2a divided by y sub 1 times quantity x minus x sub 1. This result may also be obtained by means of the calculus. Differentiating y squared equal 4ax, we obtain y dy dx equal 2a, i.e. dy dx equal 2a divided by y. Hence, as before, the equation of the tangent at x sub 1, y sub 1 is y minus y sub 1 equal dy dx sub 1 times quantity x minus x sub 1 equal 2a divided by y sub 1 times quantity x minus x sub 1. This equation may also be written y sub 1 equal 2a times quantity x plus x sub 1. Corollary. The condition that Lx plus My plus n equals 0 should be a tangent is found by comparing this equation with the equation of the tangent at the point x sub 1, y sub 1, namely 2ax minus y sub 1y plus 2ax sub 1 equal 0. Hence, L is to M is to n equal 2a is to negative y sub 1 is to 2ax sub 1 equal 4a is to negative 2y sub 1 is to y sub 1 squared Eliminating y sub 1, we have am squared equal nl, which is the tangential equation of the parabola. Analytical Conics by D.M.Y. Sommerville. Published by G. Bell & Sons, Limited. London, 1924. Read by Jim Renholt. Programming and illustration by Jim Renholt, 2022.